Hey everyone. I wish I would be speaking with you in an on-site event, but like in these unprecedented times, I'm actually glad to be with you on this on this night occasion with AWS Community Summit UK. Today I'm going to talk to you about like how actually you can take advantage of observability in serverless from development to production. And let's start like just talking about observability in general first, because observability is kind of seems regarded as a buzzword for some, and just like they think like, hey, like people just got bored saying monitoring, that's why they are now calling it observability. And like like as a starter, it's actually common to see such an attitude towards observability, but actually, observability covers everything that monitoring and testing and altogether that covers and even more. So like we do monitoring for like the failures that we can happen, but we can't actually test in our system. We do testing for the failures that we can actually reproduce at our local, and we actually combine these two to just be ready for the issues that we know. But the outside of the world, there is a kind of a universe that is actually like full of many failures. And just like these kind of matrix shows us like what we are doing, like in any software system actually there are like issues which we can be regarded as like known knowns, like we know what it is and we know how to deal with it, and like you can just like see the chart, see the spike in the chart and just like take care of it. And there are things that we know what it is, but we don't know how to solve it. There are things that we don't know what it is, but if we would know, like we could solve. And there are like things that like we either don't know and don't know how to actually deal with them. So like if you look at this chart, monitoring only actually focuses on the known failures. So like you see something and you know what to see, you know what to expect to see, and you know how to react this situation, and you just like can take the precaution that you need. And observability is actually for unknowns. So you actually make your system like ready for unknown failures, such that like whenever something wrong happens, you are actually gifted with correct tools and mechanisms and the habitual behaviors that you can actually react to this situation like again fast as possible. And as I say, observability is actually a state, while the monitoring is a kind of an activity. So like you do monitoring, but like your system becomes observable. So this is actually the biggest and the very important, like the most important difference in between. So like you do some activities, you do like we will come up in a minute, like you do some three pillars of observability, you inject those and you gather those, you extract those, and you make your system debuggable. That means like you are now an observable system. But like in monitoring, on the other hand, you just like watch something and you know what you are going to fix when you see the problem. And like observability, as I say, like lets you ask questions when you face unknown issues. But like monitoring is actually motivated to give you answers for your like pre-existing questions. And while monitoring just keeps track on the infrastructure level metrics and the logs, observability actually focuses on the application level metrics and logs. And like monitoring was and still is kind of mainly an ops discipline, while the observability is used by developers and operations people together. So like let's talk about like everyone knows about maybe the pillars, like I will explain in a minute like in more detail, but the pillars are like the logs and the metrics and the traces. So like AWS Amazon CloudWatch actually provides CloudWatch provides the logs. These are the metrics by CloudWatch, and this is X-ray. So like we somehow have the all pillars of observability in serverless. So could we say it is possible completely? So actually, there are some missing points here that like we will cover in this presentation. Like the logs and the metrics and traces are actually somehow separate than other, and the traces are not covering all of the, and also like some of the most common use cases of serverless. That's why like you need to do something yourself to actually be sure that your system is observable. And like, if you want to talk about observability challenges very briefly, so like, like Lambda runs on a container that like AWS hosts somewhere in your region, and you are just sharing this container with somebody else's Lambda. So like naturally Lambda doesn't provide you an access to underlying infrastructure, so that you cannot actually install an agent and just like try to install the agent of like a monitoring vendor, or install the your own agent. You should actually take whatever cloud vendor provides it, or you should implement something that will actually, introduce an overhead to your applications. And what I mean by overhead is actually, it's just like you need to just run kind of a sidecar process thread in your application to gather intelligence. And that should be acceptable in terms of like how lightweight Lambda functions should be. But like you need to also transport those, like the intelligence that you actually gathered yourself, to somewhere to later process it and to just like generate insights out of that. And in order to do this, like the only time that you have is actually the invocation time. So like just before invocation closes, you need to actually send these metrics to the place that you will analyze and ingest. And it will make an HTTP connection in this case, which will take like a couple of hundreds of milliseconds, which may not be very acceptable according to your use case. And even if like you manage to do some kind of magic to actually make your system observable, you make one function observable, sorry. So like you have like most of the time like many functions contributing each other and just collaborating together. So like one function triggers another, and the other function triggers another through asynchronous events, and these are like completely distributed. So like understanding one function is actually just like a very small slice of the pie. You need to just like, in order to have the full of visibility, you need to understand the whole system together. And before starting, like, let me introduce myself. And I'm Emrah Samdan. I was a developer before I transitioned to product management job for more than 6 years. I'm now like more than like it's like 2.5 years that I'm working as a product manager, and my last destination was Tundra, and still is like I'm working as a VP of product there. And I'm kindly and highly engaged with the serverless community, and I love being part of that community. I'm the co-organizer for Serverless Istanbul, and I'm the co-organizer for Serverless Turkey meetup. And just very recently, we co-organized the Serverless Days virtual with my dear friends Gunnar Grosch and Stanley Farah Campbell. And actually, I'm proud to be part of this good initiative, like in these hard times. You can reach out to me over Twitter using my name and surname, and you can always reach out to me by email, and just like we can talk about serverless. So let's now turn back to our today's agenda. So like we just like briefly summarize what serverless is and why it is actually hard to achieve well, like we just covered like what observability is and why it is hard to achieve in serverless. And like we will just like go over the 3 pillars of observability, and then we will then talk about the observability best practices at serverless. And we have something like we actually improved and developed at Tundra about like hierarchy of observability needs. So as a tool that's actually mainly focusing on the observability, we thought that, hey, this is kind of we can make an analogy between hierarchy of needs of Maslow, and we can just like transition and just like transform it to hierarchy of observability needs. So like before jumping into topic, like let's talk about like how we ended up here. So in 90s, like when I was like a small child, there was physical servers, and you were installing even programs to monitor those. You were installing like the temperature of it, like while it is sitting in your room, and just to understand like what's happening in that. And in the 2000s, like we now became like able to do some virtual machines on VMware machines, and it became like you just created some virtualization on the same server. And like in the last decade, cloud computing became like very mainstream, and we started to have distributed applications, but like these are still running on some virtual servers on the cloud, and you were just like looking at the metrics of those and try to understand what's happening. And the function as a service arrived like almost now 6 years ago, and it just brings a new paradigm to software application development. Because now you have only some piece of code that you just submit to the cloud vendor, and it just runs on an arbitrary container and that you don't know. It just runs on like the container behind this security wall or not, but you know that it will just scale up infinitely, and it will make everything that you wish to do with like less efforts of maintaining it, and it just gives you the capability of focusing on the value that you provide to your customers. It seems like a very, very nice thing, but like what you have in terms of like understanding this system, understanding health and behavior of the system is actually the logs, the metrics, and some traces, but they are all separate, and it's actually not quite enough for many use cases. So like I like this cartoon too much. So like whenever you start with serverless, you most probably start with an API gateway called a Lambda function. This Lambda function does the job that it should do, and just write the result to an SQL or NoSQL database. And just somehow like you started to taking advantage of event-driven architectures. So like a Lambda function gets triggered by API gateway again, but like instead of just like doing many things and write the results to Dynamo, it does some stuff and just notifies other functions to SNS. And then these other functions does something, notifies others to like some other asynchronous resources, or even call it directly. And in this case, like you have and like a more event-driven architecture, and your architecture becomes a Charmeleon. And after a while, you will like, as an organization, you will actually be working on serverless applications talking to each other, and like you will have like several event-driven architectures talking to each other, and your system starts looking like a Charizard. So like when there is a problem in such a distributed application, it's really hard to understand where is the problem, just to point out the problem. And actually it's also very hard to understand like what's the impact of it, and to the rest of your system and to your customers. And that's why like observability is like highly crucial for that. So let's talk about the pillars now. Like for observability, like 3 main pillars are actually traces, metrics, and logs. So like logs and metrics are something that like we are actually more used to have. Like we have some, logs are just the print statements that you are doing in your application. You can just take them out as a log. And the metrics are, you can look at some CPU level metrics or memory metrics of your functions. Like there are some other like specialized metrics for serverless that I'm coming in minutes. And traces is crucially important with serverless and also for like, distributed systems. So because like a transaction is happening through different services. So it just goes into a Lambda function, writes something to SNS, and this SNS notifies not necessarily Lambda, but also like, let's say an ECS application or Kubernetes application, and it writes something to Dynamo as a stream, and it triggers another Lambda function. So like in order to understand whole flow, you need to have a distributed tracing mechanism. So you can just build everything else on top of these pillars. You can have very fancy diagrams, you can have very fancy timelines, and just like visualize everything. You can do machine learning to generate anomaly detection, to generate, smart insights, and you can set up like automated or, the rule-based alerts that you will create on top of those. But like, if you are missing like one of the pillars, you can't actually have all of them like in a healthy situation. So like, let's talk about like what are the observability best practices in serverless. So like, I will start with the most ancient one, the logging. So in serverless, what you have is in CloudWatch, it's actually very hard to interpret the logs. Like even if you are not using CloudWatch, you are just like shipping them out to let's say to Elastic, or just looking at them through a Kibana plugin. Still, that like if you have such logs which is actually written to a JSON, it is actually saving lots of time for you. Like, I don't know, like maybe you are not hearing this for the first time, but structured logs is lifesaver for serverless. Even if like, you forget everything about this presentation and observability, just make sure that you have structured logs and you will be covered like some cases that you will face. It won't be enough, but it will be actually saving your life several times. And like, I would say use kind of wrappers or middleware libraries to automate logging when possible. So what I mean is that, like, let's say that you do an HTTP call, just use a library that actually prints the payload, or just like the URL, the request response status, and just in order to instead of you to think about like what to log, try to actually trust libraries and automate logging when possible. And just in order to, like, this kind of very obvious, but sometimes like it's being missed by many. You just need to have a strong, powerful ingestion and indexing mechanism in a center. So like, I know many companies doing Elastic using that, using Splunk for that, using our solution for that. Like, all of them are actually strong. And just instead of just keeping them on CloudWatch, it's better to have just like CloudWatch is being improved by a lot using Serverless and everything, but still like there are some more to achieve in other platforms. And like, if you are just keeping your logs on CloudWatch, please don't forget to retire that, because every gigabyte of data is costing you 3 cents. But like, when you think of a highly available serverless application, which makes like maybe millions of requests and invocations per month, like, you can actually face a really big problem in terms of CloudWatch logs. And I know like many cases that the CloudWatch logs cost is actually much more higher than Lambda cost in your AWS Lambda bill, in your AWS bill. So let's talk about the best practices about metrics. So like in serverless, there are still like critical metrics. So like, these are kind of the metrics that you would never actually think of before serverless. You need to think of like how your application is using memory, because like, if you're allocating, let's say, 1 gigabyte of memory, and your memory usage is always going around like 90% of it, you are actually in a kind of a danger zone that like your application can face some kind of a input that actually makes your application easily has an out of memory exception. Similarly, like, if you actually define a timeout of, let's say, 1 second, and your application is responding in 900 milliseconds constantly, there's a possibility that like you can hit the timeout and your system becomes like not working due to timeout errors. And you can also keep an eye on concurrent executions, just to see that if you are hitting in the concurrent execution limit of your account, or just if you are hitting the concurrent execution limit of that Lambda function. And like with serverless, application level metrics becomes more important. You can check off like the number of like 4xx errors or 5xx errors, and just like try to understand how your system is handling the traffic that's coming through. And the average duration and P99 duration is very important. So like, just similar to timeout example, you cannot understand if your function is doing well or not, like just by checking average duration. You need to check the percentile 99 duration, which means that like, what is the duration of 99 invocation out of 100 in a short interval. So in this case, you can understand what is the maximum, that if your percentile 99 is close to timeout, you should actually seriously concern about the increasing the timeout value. And you should also focus on the business context metrics, which are like the frequency of an event, the specific variable in your application. Let's say that you are just taking the ID of an user, and it's very important for you. You should actually take this as a metric and just see like how frequently you are processing the ID of a user. You may want to check this, and like you need to aggregate all of these metrics into a single pane of glass in order to gain like a better visibility. And now it comes to coming to like the hardest but the funniest part of the serverless observability pillars, the tracing. So like serverless is actually not a function only. So it's actually a function calling another function asynchronously, and just, you remember the Charizard, like you have such an architecture. So like, and in order to keep track of that, you need to have traces. And your architectures, most of the time, can talk with the third-party APIs. Let's say it just sends an email, sends an SMS to Twilio, just gets the authentication through Auth0, just like get some image from Google, like whatever it is, and it also can use some non-AWS services such as, let's say, a Redis cache or like a non-AWS SQL table through Postgre. Like such things can happen. And you need to just like, you have like the logs and metrics, and the trace is actually the glue in between. You can using traces, you can actually get the metrics and logs together. Maybe at this point, maybe I'm actually a bit late to define, but traces are actually showing the start time and end time of an activity in your system. Just thinking of this, it seems like kind of a simple one. But like when you have like multiple spans together contributing one trace, you can understand what happens. So in a span, you can say that like your application goes to service A at T0 and it just finishes its jobs at T5. And you can just put the logs and the metrics into this span. And you can see what was the application level metrics on this application service A and what was the logs printed. And you can then link this to the application goes to service B after service A. And you can just look at this as a span, and you can then aggregate the logs and metrics together. So at the end of the transaction, you have like a set of spans, which makes a trace together to actually see the whole life cycle of the application. This is what we call distributed tracing. But there are two issues. So how we are going to produce these traces? Are we X-ray, or like how can we do the job better than X-ray? And how can we actually visualize these traces just to actually solve the problems? Let's talk about how can we generate the traces first. X-ray has some problems still. So just like they brought the asynchronous call support on AWS services last year. They just brought support for SQS and SNS, but like we are still waiting for support for DynamoDB streams or Kinesis streams, and it's missing. And as I say, like for non-AWS services, we are still missing the service. And just the cure that comes to everybody's mind is actually just let's instrument ourselves. But in order to do so, like you need to actually inject relevant data, as I said. You need to inject the metrics to spans to make them more meaningful. You can also inject like some other metadata, like request response payload when you are doing an HTTP connection, and again the HTTP status code and everything else. And in order to actually correlate the spans together after the transactions finishing, you need to inject correlation IDs so that like you can actually claim that these two spans were actually part of the one single transaction. In order to do so, actually, there are open source works and initiatives started by Cloud Computing Foundation. And open tracing is the one that is being used now. And open telemetry is now under construction by just putting together open tracing and open sensors. And it will be kind of the standards and the frameworks to actually produce traces for any application. But again, just this is kind of a standard and just to make your traces like understandable by any system. But still, you need to implement according to these standards. You need to instrument every service yourself. And this actually brings us to the topic of observability-driven development. And it says that like No service can know your system better than you. So like in order to understand unknowns, you need to actually do something yourself. You need to instrument everything yourself. And you need to actually log everything in a structured log. You need to create manual instrumentation spans and just make everything ready and visible for later investigation. There are definitely some downsides of like observability-driven development, because like how can you make sure that you covered everything that can happen in your system? So in a near term, it's like what is your observability coverage, and you can't actually measure such thing. And it's actually hard to accustom to create a manual span and like logging everything possible, like, and it's just like even if you maintain it yourself, how can you make sure that your colleagues in your team is maintaining? It's kind of a cultural thing. And when you have such a thing, you can sample a thing. So I don't advise to sample like any kind of pillars in observability, but in some cases, companies might want to sample. And if you are using observability-driven development, you can't do this. So best thing that you could do is actually automated and manual instrumentation together. So instead of just like developing yourself something, use an as a service solution, put your focus on the value, and remember that this was the main point of serverless, like before everything else, and just outsource it. And if you want to embed something that's like really related with your business, you can use the tagging, and you can just embed your metadata to spans that your application is generating automatically. And you can use the entity identifiers, you can use the event types, like for example, an event comes and it notifies two functions, and another type of event comes and it notifies on some other function. Just you may want to actually log such kind of things in your observability. And you can also just tag your custom KPIs just for your other visibility. And maintaining manual instrumentation is burden, as I said. Like even if you yourself can maintain it, like when you have a bigger team, it will become harder than this. You are polluting the code. You are just like making the testing is harder, because like now you need to actually take into consideration the code that you write for the instrumentation, and you need to actually teach the same thing to every new engineer in your team. And when it comes to like the visualizing the traces, so just the charts are like the line charts or bar charts, whatever it is, like you need to have like a more time sensitive flow diagram showing what's happening between several services. And for this, there are some open source solutions. But like if it requires modification for your data, and it's becoming another thing to maintain. And just like let's say that like you like to set up alerts on top of that. Like how would you do this? So the solutions are like the most known is Jaeger and the Zipkin, and these are actually very, very powerful. But as I say, like they're powerful visualizing, but they don't actually extend functionality as they are not supposed to actually. And the best practice I can say, again, don't try to build it yourself. Focus your value, and like let's say that you build something for current stack of yourself, but after a while you will build something with some other function with some other technology, and like you will need to ask yourself, okay, now I need to maintain another observability for this. And just like take advantage of automated setup and zero maintenance, and do not try to do manual instrumentation unless you really you need. And just like visualizing such things is also hard. And just like try to have automated alerts and ability to pinpoint problem using a solution. And at Tundra, we have something that we call hierarchy of observability needs. So at top, like you should understand the whole system as a whole, and just like look at it and try to fix the errors at a glance. And just going at the bottom, you'll understand the importance of the business flows in your system, and the single transactions of business flows, and the functions which are making transactions, and the code blocks which are making functions. And just let's go over them one by one now. So in order to understand the whole serverless architecture, so like we talked about like 5 or 6 metrics per function. So let's think about like you have 100 functions in your architecture. So how would you understand such a serverless architecture? By just checking at many charts. So you can't like look at the 600 something charts at the same time. Second, that it's not possible to actually spot something wrong in such a view. Instead, like what we need to have is kind of an architectural overview of your system. In this view, you can understand what's happening in your system and just like check the problems happening in your architecture at a glance. And you can see long-running Lambda functions, and you can see problems like here. So here that you see a Redis cache that like all the incoming connections to Redis is actually showing a red error. So it seems that like there's a problem with this Redis, and it's affecting the performance of your system. And the next item is actually the business flows. So like, in serverless, as I said, like numerous times, you do distributed transactions that's happening together. Like, for example, like you are just deleting a team if you are just doing a online game, for example, and you just, this transaction happens over and over again. So like in this case, like if you have the way of keeping track of these, you can understand like some KPIs about it, like how many times it happens, how many times it was erroneous, like how long does it take, although it is asynchronous. And you need to also understand like if this is performing well or not. And this actually kind of understanding has also some side effects. So let's assume that you can keep track of every business flow in your system, and let's have that you have kind of an inventory of business flows. You can actually understand the security breaches happening, because like when you see an unexpected business flow there, you can say, hey, wait, like I was not expecting my function to visit this API, and just, hey, this should not happen here. And in this way, you can actually detect some security breaches. And also, like, it's actually helping the onboarding new engineers to your team. So you can just give this inventory to them and see that you can let them see to, hey, this is like what our system is doing in terms of business. And like, these are the functions happening here, invocations making together this, and the resources. And in this way, your new engineers can try to understand the systems like a lot faster than reading the code. And you can also have the high-level KPIs. For example, you can just like look at like how many times you deleted a team, just checking out this functionality. And the most important one is now coming, the serverless transactions. So let's say deleting a team is an asynchronous chain of invocations, and just like it happens over and over again. But like when this transaction faces a problem, you need to actually solve this problem by just checking out something else. And for this, you do distributed tracing. So you are just like tracing the distributed chain of invocations here. So API gateway triggers a Lambda writes something to SNS writes something to Lambda, trigger notifies another Lambda function, and this Lambda function writes something to SKS, and just called by other functions. So this just makes a single transaction. But like by just checking that, you can see there was an error here, you can see there was a latency here, and when there's the error, you can see the technical, like how it is propagating to other services or not, and you can see the business impact that it's being reflected to customers or not. The second, not the last, but the second one is the function invocations. So like your Lambda functions, like every function in your architecture have like several invocations, and using that, like you can just like try to understand every actually unit of compute in serverless. So you need to have like tracing for not only for the AWS calls or HTTP calls, you can also have tracing for method calls. So just like you can see how long does it take to get like some values from some method, and you can see what's the metrics like memory usage or CPU usage, and you can just reach out to logs and understand what's happening in the application. But like at this point, we can ask ourselves like, what if there's a bad coding practice? So for this, like you need to actually debug like in old days. So for that, there are and debugging is actually somehow a problematic process in serverless. So if I mean, just like if you are just using logs for that. So let's say that like you see a problem there and you just like take the logs and like, let's assume that you understand the problem. And just to verify your new solution, you need to just like first put your solution there and just you need to print new line of log and to see if it's working. And you need to redeploy this solution and then you need to see the result. And if you are lucky, it's done. If you are not, like you should see a new problem and just dig them again. And this is kind of a process that's actually taking a lot of time. For that, like what you can do is actually they can do post-execution debugging. There are some tools like ours, also like some other tools that can do actually take a snapshot of your application while it's running and lets you step through your application line by line. Using that, you can actually understand what happened in the application and see what was wrong without actually pausing or without adding any latency to your application. And the second one is actually the real-time debugging that we recently provided. So this is kind of the most product pitch part of the presentation, but I should talk about this because this is something new. We developed something for something called real-time debugging, and we developed a VS Code plugin for that, and then secure proxy just make the connection between your Lambda architecture and your IDE. So when Lambda runs on their native architecture, I mean on cloud, we are not simulating anything here. It just runs on cloud, and you put breakpoints on your IDE, and we can actually pause and play the invocation while it's running on cloud. So this is kind of the unique experience for debugging real-time applications, and it just actually helps a lot because you can play with the variables, you can play with the code, and see how it's actually changing the flow. So what are the key takeaways that we are approaching to the end of this presentation? So like, observability is not an after production issue. So you should be thinking about how you are going to understand your system, and observability is key that actually will be needed before you go to production. So you need to have all the tools and mechanisms and also cultural fit to actually use observability in production before you go into production. And you need to have like only logs or only metrics or only traces cannot help. You need to have all three aggregated together, and just in this way, you can actually understand what's happening in your architecture. And like try to use automated solutions, but like also just be ready that like you may need to ask questions yourself, because like no tool can understand your application better than you. And just like in order to understand the serverless architectures like in a more holistic way, you need to look beyond functions. You need to just look at the functions. You should continue looking at functions, but you should look at like how they are interacting with each other and how they are actually making use of an asynchronous event-driven architecture. And that's why you need to have distributed tracing out of that, and you need to also like aggregate these traces to business flows and aggregate these to to architecture. And debugging is the last but the most important. And just like till you stop doing bad coding, and then I think that that's no time. Like we will continue to make coding mistakes, and that's why you need to be able to debug your application after execution or just doing the invocation with our new feature. Thank you everyone who is listening to me today. It was my pleasure.